to Man BMW Camshaft less engines training course. This is module 4. This is a fairly long module and one of the most important chapter of in this course, because in this module you will learn how to check the parameters, engine parameter, how to adjust the engine parameter, how to adjust the engine load, how to balance the engine. So go through this chapter carefully, and you can always repeat the chapter because it's always available to you. It's free of cost of course. All right. Welcome to the Man BMW camshaft-less engines, MEC engines. Today we'll talk about MOP and LOP. I have divided this module in two parts, module 4.1. So we'll go through the module 4.1 first. So MOP is main operating panel and LOP is local operating panel. So we'll see what all we can do and how does it help us in running in the engine. So next navigation bar, as I told you, six uh, navigation bar. Second one is engine. Of course, this navigation bar is one which most of the time operator will be here on this screen, one of the screen of the engine. The number of sub screen, because here you will see a monitor, parameters, view the system, change the running parameters whenever required. So this is very interesting, very important also. All right. So let's go and see this engine. So operator shall be interacting with this navigation bar whenever operate monitoring and adjusting if parameters are needed. Whenever adjustment of parameters are needed, this is the sub navigation bar which you will be using. One of these five screens is required to carry out adjustment as required. So there will be sub screen. So we'll see what all the sub screens are. There is further five sub screen in this section. So there are five sub screen in this section. So let us see what are those five sub screens. Sub screens are operation, operation of the engine, status of the engine, process information. What is the information of various processes? Process adjustment. In, actually, all of these will have tabs also. Navigation bars and then sub bars. Then there are tabs. On top you will find tabs. You know computer system, no? There are tabs, one, two, three, different tabs. Process adjustment, and these there are different tabs. Auto tuning, cylinder load, cylinder pressure, fuel quality. Some may not have, let's say, fuel quality, for example, and chief limiters. So there are 1, 2, 3, 4, 5. Operation, status, process information, process adjustment of cylinder load, cylinder pressure, and fuel quality. Auto tuning also possible, but auto tuning has to be provided. It is only available in CocoOS, EDS, not basic version, and chief limiter. So we will learn about this because for operation, these are the sub-screen operator will be often come for checks and adjustment. During operation time, you will be keep checking the parameters, but if you need to adjustment, then you have to go to adjustment and you will change as required. Of course, after taking performance. Operation, status, and process information are related to engine startup preparation and normal running of the engine. All right. Process adjustment. So operation status and process information are related to engine startup preparation. When you're running, you're in the port and you're now starting the engine and normal running of the engine. Process adjustment or cylinder load and chief limiters or cylinder pressure screen are used when adjustment to the engine are required and are to be carried out. Of course, after taking performance, because of the need to adjust the cylinder pressure, say a peak pressure, for example, or engine balancing as we call it, or put certain limitation. For some reason, you want to cut out number 3 unit, you have to go to this screen. This is what it is. And then operator, when you're in the operation screen, can access these 5 operations from the navigation bar, engine, and its subscreen are as stated. So we are here on now operation screen. Operation screen, you can see emission or economy mode, governor mode. Hmm. So these parameters you can see. Auto mode. Hmm. All right. Now video 4. Operation. So this screen is used when the operator is preparing the engine for departure. On this screen, when condition required for the engine to run are met, that means prepare start is pressed. Naturally, prepare start function is only available when engine is at stop. Of course, pressing this button will start pre-lubrication of the cylinder and also start the auxiliary blowers with indicator cocks open. Slow button when you press, you, you can check for visual inspection from the indicator valve that nothing is coming out, no water or no oil if it were dripping. What we call commonly blow through. So this is the way we carry out blow through. Throat run will take place as long as telegraph is in position. Dead slow ahead or dead slow start. Normally we do in dead slow ahead. Normally telegraph has to be moved, of course, with the bridge permission. So this is what you are carrying a pre-lubrication also. Of course, engine-driven hydraulic pump must be running. Indicator cock must be open. Or prepare start condition must met. Turning gear, disengage, automatic starting a start valve in auto position. All those things must be there. Here I point to make that some chief engineers are using air run to blow through. Air run is different. Manual does not recommend that. However, follow the whatever practice advised by your technical department. My suggestion is use throat run for blow through. Okay. Another thing is air run can only be used in the chief mode. That means access mode has to be taken to the chief mode. Use the password Badoit and go to chief mode. Then only you can use your air run. But slow turning can be done in operator mode also. But normally duty engineer will be preparing the engine. Chief engineer may not be there, will not be there. Or also senior engineer may or may not be there, depending on what is the procedure you follow on your ship. Hmm. Air run is only available in the chief mode. Air run is used carrying out starting air valve test, for example, after maintenance. Just to check no leakage and all. That time you use air run. Checking and testing tacho system. That time you use air run. Only difference between air run and slow turn is that in air run, main starting valve admits air through the main line. And in slow turn valve with a smaller pipe, air will enter. So naturally, you are doing blow through. This pressure is good enough to whatever if there was some deposit of water particle, water dropping, water dripping or leaking or oil dripping, it will come out. So this is the intention. Why you want to use a larger pipe, more amount of air, just to blow through? No need. Since this facility is available, use slow turn. Use slow turn. Once slow turn and prepare start is completed and indicator cocks are closed, then push the auto button. Engine is ready now. Put and give the control to the bridge. Of course, other things must be running. Air, share, everything, all must be leaving. Now the engine is ready to start position and will start as per the command given by the telegraph, wherever the control is, on the bridge or in the engine room, in the control room. All right. So above condition will function when main state field is standby. Of course, you have to be in the standby condition. You cannot be on a run up or finish with the engine and do all this thing. Not possible. Again, I said it is foolproof, idiot proof. Put it in the standby, and the color is blue, not yellow. If yellow, warning state, or red, alarm state, or dim, not accessible, not in use, not available. So main field will have one of these three command state: finish with engine, standby, or at sea, or run up, whatever. Please also note there are two running modes available: economy and emission. In emission mode, ME engines are able to meet more stringent requirement than Tier 2 norms. Tier 2 norms are also met in economy mode, but it does not meet Tier 3 norms even in emission mode. Tier 3 norms has to be met by HPSCR or LPSCR or exhaust gas series regulation. Remember that. In emission mode, there will be a rise in specific fuel consumption. So normally economy mode is good enough. If certain states, certain ports, certain areas you need more stringent requirement than Tier 2, but not exactly Tier 3, then you can use this economy emission mode. So in emission mode, what happens? Again, I see NOx emissions are reduced. This I'm talking about NOx emission, not the sulfur emission. Sulfur emission is different. For sulfur emission, simple thing is either use the low sulfur fuel or use a scrubber. NOx emission, economic mode, higher SFOC, normal injection, normal pressure, compression, and peak pressure. Higher the peak pressure, lower the specific fuel consumption. In emission control mode, what is done? Maybe injection is done twice in a cycle. For the test cylinder, it part injection and then in once again injection. So the peak pressure are reduced. Peak pressure reduced, that is how the NOx emissions are reduced. As I told you, nitrogen is an inert gas. It does not react with the oxygen. It reacts with oxygen only when pressure and temperature is very high, as they occur during combustion of the fuel. Because it's an explosion, very high temperature. If you can lower the temperature a little bit, lesser NOx emission will be produced. That is what is being done in emission mode. Okay. So there are three governor modes: RPM mode, torque mode, and index mode. All these things you can choose, whatever you, as per your running requirement, running of the engine, what is the condition. So the speed control can be requested to calculate the fuel index according to various modes of the governor. So what it does, basically ECU is a governor, carries out the governing function. So according to the governor mode in use, RPM mode or torque mode or index mode, the controller, speed controller or speed governor or whatever you can call it, or ECU will calculate the amount of fuel or in turn fuel index and control that so that it follows the requirement of RPM mode, torque mode, or index mode. So each method is referred to as a governor mode and they represent various tolerances for maintaining the engine speed equal to the set point during load and or set point variation. So for normal operation, you use two modes. Which are two modes of all these things? All these three. What do you suggest? RPM mode and torque mode, or RPM mode and index mode, or torque mode and index mode? What do you say? And RPM mode, or torque mode and index mode? What are two modes? It is normally RPM mode and torque mode, either RPM or torque mode. Index mode is generally not used. I'll tell you why. So speed mode provides the most rigid speed control. Whatever the RPM we put, your control system will try to maintain the RPM. Of course, the index variation may take place, large variation may take place. Normally, you use this RPM mode when C is normal, not choppy or something. So you keep whatever RPM you want, you keep that RPM, your control system will maintain that RPM. When do you keep torque mode? Here, the speed variation is dampened. Speed mod is dampened. All right. So unless when the speed little bit drops within the range, no fuel will extra fuel will go, because each fuel RPM will have certain amount of fuel, no more. No more fuel can go. So this is actually advantage, yes, when there is a choppy sea, rough sea, not kind of rough sea. So what is happening? It will allow the RPM to drop, but will not increase the fuel, or basically the fuel index. So that means the speed control is dampened when the speed is close to the required speed, providing speed control without large index variation, but allowing larger speed variation. So RPM will drop, but will extra fuel will not be released. So basically, it maintains the fuel index kind of, but of course, certain range. So your engine does not get overloaded. A third mode is exists, that is index mode. When do we use index mode? Normally, it is not used. When do we use index mode? Index mode when you are taking performance. Fixed fuel index mode when main engine performance is being taken. It is desirable that the index is kept constant because you're taking performance. All units should get the same amount of fuel as long as the speed is within a preset range. And you always take performance when the sea is calm. Try to take performance when the sea is as calm as a glass sheet of glass, which is not always possible. Only if the speed drift outside this range will the speed controller become active and regulate the index. This mode is ideal for taking performance, engine performance, and normally not in use except when performance are taken. So remember this. Okay. Next slide. Now, operation we have gone through. Now comes status. When start conditions are met, main starting valve in auto position, turning a disengage, etc., then the main field will have green ticks with blue background. All this will be main starting a valve tick, starting a distribute tick, 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 tick. Auxiliary blower, hydraulic pressure, power supply, hydraulic pressure. So this is a slow turn valve, as I am telling you. Which will open this valve, and this is the main start line. Slow turn. Main. When you do the air blow, air run, air will go through this line. When you do the slow turn, air will go through this line. This will remain closed. So another view of the status. Pressing the button details will show the crank position. Here, if you press the detail, it will show the crank position when engine is running. All right. Process information. Operator gets an overview on the screen of the running mode of the engine, economy or emission. Here you can change economy mode or emission mode. No other screen. PCOM by P scavenge is calculated using absolute pressure, not the gauge pressure. Remember this. So, meaning atmospheric pressure is required to be added to the scavenge pressure to get absolute pressure. This value is used for setting compression ratio offset. We'll see a little later. So here, when we're talking about P compression or compression ratio offset, we'll be using compression pressure and we'll be using scavenge pressure. Here, the scavenge pressure is not the pressure which your system is giving you. Let's say it's giving you a value of 1.25. You have to add approximately 1 bar, which is atmospheric pressure, to make it 2.525, and divide peak compression by that. That will give you value of ratio of compression ratio offset. Confusing? No, it's simple. No. All right, because all the pressure what we read are above the atmospheric pressure. We call them gauge pressure. In this case, we are using the absolute pressure. Absolute pressure. So here, for example, process information, and you go to the running mode. Running mode you can change economy or emission. If you use economy mode will be used. If you come see on the bottom emission, emission mode will be in use. And it will tell you the estimated engine load, maximum pressure, P max. This value it will give you, system will give you. Compression pressure, 130 bar, P com by P scavenge, 35.5 bar. This remember what I was telling you. Scavenge pressure, exhaust valve operation, scavenge pressure 2.69. If you divide 130 by 2.69, what is the value? Calculate. So this is actual. So this you have to add 1 bar, then use actually here. Because then only you will get the value 35.5. You can calculate. So speed set, what is the speed set? Okay, this is some other engine where RPM is much higher. Normally our engine slow speed are RPM anywhere between 60, 55, 60 to 80, normal. So don't bother about this, but this is what it is. So fuel index set point, hydraulic oil pressure. Normally 300 bar is kept. Here it is 207 bar. PHK power here P scavenge set point 2.93 has been set, but this is the actual value. Hydraulic pressure 207 has been set, but actual value is 207 bar. So the screen which is lighter in color, that is the set point, and the darker range, this is the actual value. Okay. Another screen, speed control. Next, go to screen speed control, but in the same process information. You will get bridge mode, where is the command center, RPM, speed set, which is RPM set, index, which is what is the percentage of index right now, fuel index percentage, limit is 66, actually 30, but chief engineer said the index limit 66. Speed RPM 100. So stabilizing, stop, minimum speed, maximum speed, fixed speed set, shutdown, etc. These are the limiters I was telling you. Start limiter, chief limiter, scavenge air pressure limiter, torque limiter, hydraulic power limiter, temperature control limiter if you have fitted with scavenge control unit, SCU. So what is the meaning of start limiter? Start limiter means certain amount of oil, fuel will be released during start. Only that, but no more. When you're starting the engine, certain amount of fuel will go. So the amount of fuel is limited by the start limiter. Unlimited amount of fuel will not go. For example, suddenly too much load come from the front, or some ship had passed, there is a wake, and you then only that time only the movement was given. So engine try to turn, but too much load, it may misfire, possibly, whatever reason. So certain amount of fuel only can be released in the start limit, as limited by the start limiter. Chief limiter is the amount of fuel which is limited by the chief. This much only fuel will go. That means the RPM cannot increase more than so and so. Or one particular unit he can also reduce, or all unit he can reduce. So this is what we call chief limiter. If you make chief limiter 0 of particular unit or any one of the units, that unit is cut off. So cutting off the unit becomes so simple. Just bring the chief limiter to 0 or unit is cut off. No fuel will be injected. All other things will be working. The fuel will be cut off. Now scavenge air pressure. This we all know skill limiter. So much scavenge air pressure, so much fuel can only be released. This we have been using since ages. Torque limiter. Once you use the torque limiter, I said every RPM has certain amount of fuel. No more. So when your torque limiter in use, So and so RPM means only so much fuel can go, no more. Hydraulic power supply limiter, also same thing. So much hydraulic pressure, so much fuel can go maximum. If for some reason hydraulic pressure drops, for lower hydraulic pressure, only certain amount of fuel can go. That means RPM will drop automatically. No more RPM. Hmm? Remember? Okay. Turbocharger cutout, of course, when turbocharger cutout mode is there. So that limiter, when turbocharger is cut out, for whatever reason, of course, so much amount of fuel will go. So this is the process information. Then comes the process adjustment. So limiter, which one in use can be seen in the on the screen. There are primarily 5 limiters. Start limiter, how much fuel is to be released at the start. No more. Chief limiter, fuel limit set by the chief for each individual cylinder. Scavenger pressure limiter, fuel limited by the scavenger pressure. Torque limiter, the maximum amount of fuel which can be released for the given RPM. So much RPM, only so much fuel can be released, no more. These to ensure engine torque does not exceed recommended value and engine never gets overloaded. Hydraulic power limiter, hydraulic pressure determines how much fuel can be released for the given hydraulic pressure. In case turbocharger cutout option is available, fuel index will be limited when the engine is running in turbocharger cutout mode. Naturally, but one turbocharger is cut off. All right. We'll see process adjustment. Process adjustment. On this navigation bar, there are 4 tabs. Tabs mean on top. Navigation bar on the sides, toolbar at the bottom, tabs on the top. Okay. Auto tuning, cylinder load, cylinder pressure, fuel quality. Adjustment of the engine balancing will be carried out on this process adjustment navigation bar. So two methods for adjustment of combustion pressure are available. Manual adjustment carried out by the operator. Auto tuning, auto tuning itself means engine will is continuously being balanced, parameters being changed when as required. So needless to say, item 1, auto tuning functions are available only if chosen in the specification. Auto tuning, it will not be there on all ships. The version has to be there, system has to be fitted. Advanced version of the COCOS ETS. We will learn here how the manual adjustment are carried out. 4 tabs: auto tuning, cylinder load, cylinder pressure, fuel quality. Auto tuning doesn't require any introduction because auto tuning means it is balancing the engine out on its own as per the given algorithm. If you are using that, engine will be balanced on its own. When you are using cylinder load, here we can balance high in load offset and low load offset. Two offset we can provide. High load offset, low load offset. What is that? Actually, you run the engine at lower load possible and adjust the low load offset. Once you adjusted that, only certain range is given, no more. What is the range? Here, 5 plus minus 5 only. Percentage. This is in percentage, remember. And high load offset plus minus 10% is available. How to do it and what is the meaning of how to calculate the value of offset, I will tell you. Patient, I'll tell you. Cylinder load. From this screen, from this subscreen or tab, an operator can adjust the load of an individual cylinder. We know the power delivered by a cylinder load of cylinder is. What is the power delivered by the cylinder? Power delivered is proportional to the mean effective pressure of the cylinder. Other thing remaining constant. Correct? Mean effective pressure. No. Other things are constant. Mean effective pressure is the one which is varying. And that will determine how much power is delivered by the cylinder. That means higher the PI, mean indicator pressure or mean effective pressure, higher the load. We can balance engine load by ensuring individual cylinder develop equal power between them. For some reason, some may be developing more power, some can be developing less power. So engine is balancing is carried out at two engine load. When engine is running at highest possible load, when engine is running at lowest possible load. So value offset is to be calculated and entered. Actually, first we always do run the engine at low load. So first we adjust low load offset. Then we adjust the high load offset. Okay, although I mentioned high low load first, but remember, run the engine at lowest possible load and set the low load offset. This calculation is a little long, different, so I will discuss in different module altogether. So another module I'll discuss. Otherwise, this will become too long. All right, got it? Then comes cylinder pressure. In this screen, operator can ensure that deviation between different Pmaxes of different units is within acceptable range. What is the engine maker recommended values of Pmax differential between different units, or what is your company policy? Anybody can tell. Normally it is plus minus 3 bar. The deviation between different units must not be more than 3 bars. Pmax all. Pmax for all cylinder can be increased. Actually, balancing of Pmax means two things we can do. Balance the engine by balancing the Pmax of all units, or increasing the Pmax of all units together. That's in common Pmax. So Pmax, let's say this is the average Pmax. You can increase the average Pmax. One thing, so all unit Pmax will rise. Other thing is one unit Pmax this much, other one is this much, another one is this much. So you balance that. So there are two balancing. So when you are balancing the Pmax of all unit, it is equivalent to VIT, isn't it? What is VIT? VIT is even when engine is running, let's say 80% MCR, you increase the Pmax as what it would have been had the engine been running at 100% load. Correct. So we increase the Pmax, which is efficient. Increase the efficiency of the engine, lower the specific fuel consumption. So when carrying out Pmax, all setting at low load, it is necessary to confirm Pmax is not too high if engine is then run at high load. Now remember, if you are adjusting Pmax when running at, let's say, 55% MCR or lower load, 30% load, or slow steaming, that time you adjust Pmax. So do not forget to adjust again when you run the engine at high load. So Pmax can be too much, more than the permissible limits. All right. Calculation again, I will tell you. So cylinder load we have done, this cylinder pressure, this is Pmax, and it's done directly. Very simple. Minus 20 to plus 20 bars is allowed, and that value can be inputted directly. Number 4, you need one to increase by 2 bar, just increase by 2 bar. All units want to common. You want to increase by 3 bar, increase by 3 bar. So simple. Huh? Life has become cool, man. Huh? You guys are lucky. Huh? Now, modern time, machines are helping you. They are writing their own codes, AI and all. We don't know what will happen. Nobody knows what is happening with the AI. It may be very risky. AI is learning to write its own code because it's learning what we are telling him. It's learning now, and I have started doing things on its own. Anyway, now P cam by P ischemic offset. This is also called combustion ratio offset. This value is also need to be calculated, and value here is minus 2 to plus 2 only. Basically, it's adjustment of exhaust valve closing timing. exhaust valve closing timing. Exhaust valve open timing is also adjustable directly by doing. Here only you can retard, delay the timing, not advance the timing. So exhaust valve open at 110 degree centigrade, you can open it at 111 or 112, but you cannot open it at 108. These are process adjustment, engine balancing. All right. So PCOM by P scavenge offset can be set here. Remember to use absolute scavenge pressure. Again, I am repeating again. Scavenge pressure to be used is absolute pressure. That means whatever scavenge pressure is there, add atmospheric pressure that is approximately 1 bar and make is whatever value comes, divide that by compression ratio, so get to the offset. PCOM by P scavenge offset. So that is adding atmospheric pressure to the gauge reading of the scavenge pressure. So what is the effect of this setting? By setting PCOM by P scavenge offset value plus to minus 2 degree is actually affecting closing of the exhaust valve. Exhaust valve will close early or later. So if the exhaust valve is closed later, what difference will it make to the cylinder pressure? Tell me. You should know be able to answer this because I have told you earlier. Okay. If the exhaust valve is closed earlier, what difference will it make to the cylinder pressure? You should be able to answer this question. If not, go back to the older module. Go through again and find out. Otherwise, you can find out somewhere else also. If I'm taking class online, I will tell you. But now, this time, I'll not tell you because you are learning on your own. You have to go back and learn. Sorry. Okay? Don't worry. Learning is always fun, isn't it? When you find something so joyful. Remember when you were a kid, suddenly you find something which you are missing. So joyful. So learning and finding things are always make person happy. So keep learning, keep finding things. Okay. Exhaust valve opening time. Exhaust valve opening can be delayed by 2 degrees if needed. What is the effect of delayed opening of the exhaust valve? Again, you should be able to answer the question. All right. Fuel quality. Fuel oil index for oil center can be increased or decreased as required when fuel is bunkered and its calorific value changes or substantially. Naturally, when you take bunker, calorific value of fuel is different. Remember, the system which is calculating values in your ACS is based on certain calorific value. Because you remember, if you can calculate power developed by your engine by finding out how much fuel is being consumed. On that basis, you can calculate the power. But in that case, you take the calorific value, some value you take. If you do not know the calorific value or some arbitrary value you take, the, the power you have calculated will not be the correct value. So you have to know the correct value of the calorific value. All right. Remember, sometimes, most ships, I think, your IOPP certificate, it does not give the how many liters you can burn in your incinerator. Now I do not know. Earlier I remember. It will give you calorific value. So much calorific value of fuel you can run for so much time, so much fuel will burn. So amount you have to calculate yourself. So that is the calorie value of the incinerator. Something like that. I think you're getting me what I'm saying. You're intelligent. Okay. When the values are put in the calorific value of the bunker supplied and its density, a value will be calculated for the fuel quality offset. So when you receive the bunker and the value of the calorific value is given by the supplier and their density is also given by the supplier, you put this value in your system, a fuel quality offset will be calculated for you. But this value, calculated value which the system has calculated, will not affect the engine unless you apply this value. This value has to be applied to the system. There are two things. System will calculate values for offset, fuel quality offset, when you put the value of the calorific value of the new fuel and density of the new fuel. It will calculate and give you the value. Now this value has to be applied. This offset has to be applied. Otherwise, if you do not apply, the engine which power it calculates, it will be incorrectly calculated because it will continue to calculate based on the older calorific value. Remember? So the calculated fuel quality offset is just a good starting point for finding the correct applied fuel quality offset. So use the calculated fuel quality offset. This is the starting value. Now you see what is the calculated value. Now what is the value it's calculating and tell you, and take performance. And compare. Then you can make necessary adjustment. Make sure what you have taken performance and what it's showing is the same. Then you don't have to do anything till the time you consuming this bunker. So then it is essential that internal load calculation by the AC is the same as the external performance taken. External performance you have taken and what the ACS has calculated. So mismatch between internal and external load estimation can give rise to a wide range of problems, including but not limited to poor fuel index limiter, wrong cylinder pressures, and wrong cylinder lubricating oil usage. Isn't it? This is what fuel tap quality means, fuel quality. So this is the many companies are saying now don't use kilocalorific values. They use millijoules, megajoules. Okay. So calculate a reference value. This is your lower calorific value of the fuel, the density you have provided. This is the calorific reference value the system was giving you. And this is the calculated quality offset because you have received the fuel with the value of 45,000 megajoules per kg. Okay, 45. This is cubic meter, 45. And this is the density. So it will calculate some value and give you, but it will not start utilizing this value to calculate the power developed by the engine because your system is said calculate the power developed by the system. Remember earlier you had seen process information in the process information. So this value applied quality. Now you can decide to apply this value or different value. So set and save lower calorific value, set and save density, set and apply fuel quality offset. So here you can change the lower calorific value. If you change new value, put it up and use this cursor, this lower or increasing signs, and save. All right. On this screen, chief engineer can set the maximum engine speed. That means that so much amount of fuel will go only so particular cylinder. So that's because chief engineer set it, you call it chief limiter. Can set the maximum amount of fuel for all of each cylinder may receive. Can cut out one or more cylinder. How? Make it zero. Chief limiter, you make zero, no fuel going. Exhaust valve operation can be disabled in the screen. I'll show you now if needed and enabled again. Available state of all HU can be seen and it is possible to reset failure if required. All right. It is not available. Status of SU is not available on version, depending on what software version is fitted on your ship. Chief limiter. So in this case, maximum RPM, engine, maximum speed, whatever. Now, here is the chief limiter. You can make it more, you can make it zero. You can increase all, or you can lower it for all units. For some reason, you want tell the bridge don't go more than 80 rpm, more than 17 rpm. For all the units, instead of controlling each individual unit, you do it from here. All units, no unit will get basically kind of field reg. For example, you can say exhaust valve operation can be now enabled or disabled. If you cut off the unit, engine is running, the exhaust valve opening closing. If you want, you can keep the engine exhaust valve closed, or keep the exhaust valve in open position. But that position you have to be done manually when the engine is stopped. The tools and all is there, that is given in the manual. You can open exhaust valve can be manually kept open. There is a method. Okay, this I am not discussing here. HCU status. Actually, it's not available on all ships. Some ship it is available, some ship it is not available. You can reset normal or abnormal. For example, if you cut off the unit, for example, number 4 unit, you have cut off, exhaust valve you have stopped, disabled, SU also you can disable, because nothing now. Cylinder lubrication you can provide with the emergency lubrication, which I told you earlier. Is it done? Okay.